Myself, MP Singh, PGT Chemistry from JNV Bhushal, Jalgaon, is going to present about the redox reactions. In the lower classes, we have seen about the oxidation and reductions. Firstly, we shall try to know about what is the redox reactions. The reactions in which oxidation and reductions both takes place simultaneously is called redox reactions. So now let us see one examples. Redox reactions means oxidation and reductions. Oxidation and reduction both takes place simultaneously. Is called redox reactions. The redox reactions is defined as the reactions in which oxidation and reductions both takes place simultaneously. Now let us see what is the oxidation. In the lower class we have studied about the oxidations. So oxidation is defined as in the different 5 ways. It is a chemical process. It is a chemical process in which the addition of oxygen takes place. The addition of oxygens second definition is removal of hydrogens. Another definition is increase the proportion of electronegative elements. Another definition is increase in oxidation number. And one more definition is loss of electrons. Takes place is called oxidation. So oxidation is defined as in the 5 different ways. The first definition is addition of oxygens, removal of hydrogens, increase the proportion of electronegative elements, increase in oxidation number, and loss of electron takes place is called oxidations. Reduction is just reverse of oxidations. So reductions may be defined as it is a chemical process in which removal of oxygens, addition of hydrogens, decrease the proportion of electronegative elements, decrease in oxidation number, and gain of electron is called reductions. The redox reaction is the reaction in which oxidation and reduction takes place simultaneously. Now let us see one example. Suppose that ZnO plus C, zinc oxide reacts with carbons to form Zn. Carbon is reducing agent, so it reduces zinc oxide into metallic zinc and it forms carbon monoxide. By the oxidation method, The oxidation number of zinc is +2 and carbon is 0. And in this product, the oxidation number of zinc is 0 and the oxidation number of carbon is what is it? 2. Because the sum of oxidation number of element is equal to 0. In the most of the compounds, the oxidation number of carbon is taken as -2. So simply we can calculate x minus 2 is equal to 0. Therefore, x is equal to +2. Zinc is in a free elemental state, so its oxidation number is 0. So it is clear from the examples that the oxidation number of a zinc gets decreased from 2 to 0. So it is a reduction process. It is a reduction. The oxidation number of carbon is 0 and the product is oxidation number gets increased by 2. So here the carbon is gets oxidized. So this process is called oxidation. So it is clear from this example that in this reactions oxidation and reductions both taking place simultaneously. So just we have revised these chapters. Now let us see one familiar examples about the redox reactions. So now let us see with and examples. So very familiar example of redox reaction is galvanic cells. Galvanic cells. So what is the galvanic cell? So it is a device in which chemical energy is converted into electrical energy. Galvanic cell is a device in which chemical energy is converted into electrical energy. Now let us see it as a one demonstrations. So in the galvanic cell there are the two vessels. In the galvanic cell there are the two vessels. We can take two beakers. Just they have taken two beakers. In one beaker, zinc sulfate solutions is placed in one beaker, and another beaker, copper sulfate solutions placed in the another beakers. In the zinc sulfate, zinc rod is dipped. This is a zinc sulfate solutions in which zinc rod is immersed. In the another vessels, there is a copper electrodes, and this is a zinc electrodes. The zinc electrode is connected through a connecting wires provided with a galvanometers with a key and jockey. With a key and jockey and connected with a copper electrodes. So now let us see once more how this apparatus is set up, how the galvanic cell is represented. So firstly we have seen that galvanic cell is a device in which chemical energy is converted into electrical energy. So now let us see its constructions. Constructions of galvanic cells. Constructions of galvanic cell. Its familiar example is Daniel cells. So in a galvanic cell, there are the two vessels, there are the two beakers. In one beaker, zinc electrode is dipped into zinc sulfate solutions, and the another vessels, copper electrode is dipped into copper sulfate solutions. And both electrodes are connected through a galvanometer provided with key and jockey. When key depressed, there is no flow of electric currents. There is no deflections in the galvanometer. Now let us see. This is a we have taken two beakers for demonstration purpose. So this beaker contains zinc sulfate solutions and this beaker contains copper sulfate solutions. And zinc electrode is dipped into zinc sulfate solutions and copper electrode is dipped into copper sulfate solutions. Both electrodes are connected through a connecting wires with a voltmeters provided with a key and jockey. This is the key and jockey. And when key is pressed, it shows deflections. It shows deflection in the galvanometer. It means it shows deflection in the galvanometer. This indicates that electric current is flowing through the circuits. Electric current is flowing through the circuit. So now let us see what is the reaction taking place. So there are the two types of reactions. Zinc ore being high electrode potentials, so it undergoes oxidations. So now let us see cell reactions. So there are the two types of reactions. One is called aerodic half cell reactions, which taking place on the left hand side. Both electrodes are connected through a salt bridge. So this one is a salt bridge. So both electrodes are connected through a salt bridge. So when key is pressed, it shows deflection in the galvanometer, which clearly indicates that electric current is flowing through the circuits. Now let us see cell reactions. So anodic half cell reactions, there are two types of cell reactions. One is called anodic half cell reactions. So zinc that goes into solutions as a Zn plus 2 plus it liberates 2 electrons. This process is called oxidation. Loss of electrons is taking place, so it is a process of oxidation. Cathodic half cell reactions. Now let us see cathodic half cell reactions. Copper is dipped into copper sulfate solution. So there is a copper 2 ions equal solutions and it captures 2 electrons and that is converted into copper solid. So this process is of course reduction. Gain of electron is equal to reductions. So in these galvanic cells, oxidation and reductions both taking place. So overall, now let us see overall net cell reactions. What should be the net cell reaction? क्या होना चाहिए net cell reaction? So both electrons cancel out. So the overall net cell reaction is zinc solids plus copper plus 2 equals, that is converted into Zn plus 2 equals plus CuS. So So this is the net cell reactions. So in these reactions, the oxidation number of zinc is 0 and here plus 2. The oxidation number of copper ions is plus 2 and in this case copper is 0. So here the oxidation number of zinc increases. So this is a oxidation process. The oxidation number of copper gets reduced from plus 2 to 0. So this must be called reductions. So it is a very familiar example of redox reactions. So it is clear from this reaction that in the galvanic cell, oxidation and reduction both taking place simultaneously. Now let us see what is the observation in this galvanic cell. Now let us see what is the observations. Observations. After the reactions, we observe that the zinc rods becomes thinner and thinner. The zinc rod becomes thinner and thinner because from the zinc metals, zinc ion is going as a ions as a Zn plus 2. So first observation is now let us see observations point. Observations. Zinc rod becomes thinner and thinner. Second observations means since zinc ion is going in a solution, so the concentration of zinc sulfate increases. Second observations, concentration of zinc sulfate increases. Third observation is here copper ions captures 2 electrons and converted into copper solid. So the concentration of copper sulfate decreases. Concentration of copper sulfate decreases. On the copper electrodes, copper gets deposited. So copper rod becomes thicker and thicker. Copper rod becomes thicker and thicker. Copper rod becomes thicker and thicker. Now let us see the zinc. I need to liberate 2 electrons. So the flow of electron taking place from zinc rod to copper electrodes. Next one is flow of electrons. Flow of electron takes place from copper to from zinc electrodes to copper electrodes. As it mentions that the flow of electric current is always in opposite direction of the flow of electrons. So electric currents flow from copper electrode to zinc electrodes. So this is the observations in the galvanic cells. So now let us see MCQ type questions. MCQ type questions. In the galvanic cells, now let us see one questions. In the galvanic cell, in the galvanic cell, first points, copper rod becomes thinner and thinner. Copper rod becomes thinner and thinner. Thinner and thinner. Second point, oxidation takes place at copper electrodes. See, the concentration of copper sulfate increases, and next options, none of these. So this is one MCQ type of questions. What will happen? From the observation, it is clear that copper rod becomes thinner and thinner. It is not possible because copper rod becomes thicker and thicker as we observed here. So this option is not possible. Oxidation takes place at copper electrode. Here we see that copper gains electrons. So at the copper electrodes, there is a reduction. So oxidation is not taking place at the copper electrode. So this is also not a correct option. The concentration of copper sulfate increases. Is it true?
Yes.
The concentration of copper sulfate increases. It is also not true, because copper sulfate concentration is decreasing. Copper ion is converted into metallic copper. Copper ions are getting decreased. So the concentration of copper sulfate not increasing. So it is not a correct option. So what should be correct answer? None of these. So this is the correct options. So in this topic today we have seen redox reactions, and the very familiar example of reduction is a galvanic cell. So galvanic cell is a device in which oxidation and reductions both taking place. So in the next class we shall discuss about the cell representations. How cell representation. So in the next video we shall discuss about the cell representation. Okay, thank you.